So when the ball strikes the ground, it rebounds with 1/5 of the speed which it strikes the ground. So I'm just going to extend my sketch. So when it hits the ground, it rebounds again and again, remember? So at the highest point, the velocity is going to be equal to 0. But the speed when it rebounds is going to be 1/5 of the speed which it strikes the ground. So we find out from part A that when it strikes the ground, it's going to be 42.7. But when it rebounds, so the initial speed is going to be 1/5. So we need to times that by 1/5, which is 8.54. So we know when it rebounds, so the initial velocity is going to be 8.54. So we want to find the greatest height when it rebounds from the floor. So we want to find out this distance here. So let's do a SWAT. So remember, we always do our SWAT as our second step. So the displacement, which is the height from here to here, this is what we want to find out, which we don't know. The initial, so the initial is this here, we just worked out, is 8.54. The final velocity, which is the top, so we know this is 0. And again, acceleration is gravity, which is minus 9.8. Then t, we're not given this information. So again, looking back at our 5 formulas we read at the start of the test, we're going to use the one with no t, which is going to be this one here. So no value for t. So we're going to use v squared equals 2as plus u squared. So we want to use the one with no t, so it's v squared equals 2as plus u squared. Substitute our values, so v squared is 0, 2 times minus 9.8 times by s, plus our u, which is 8.54 squared. So 2 times 9.8 is going to be minus 19.6 s plus 8.54 squared, 72.9316. So 0. So we're just going to rearrange. So we know 19.6 s equals to 72.9316. So we know s is going to equals to 3.721, or we could just write 3SF as 3.72. So the highest it's going to bounce up is 3.72 meters.